Hello students, welcome to Math Fam. So we'll be taking our topic today, simultaneous equation. Right now here, whenever you talk about simultaneous equations, we are going to take here linear and non-linear, both type of simultaneous equation. So before we start our session, what is the meaning of linear equation? Because here first, whenever you are talking about simultaneous linear equation, you will learn two types of equations, linear and quadratic equation. So first, what is the meaning of linear equation? Any equation where the number of variables can be anything, but the highest power of the variable should be 1. That means degree of the equation should be 1, then it is known as linear equation. Then what is the application of simultaneous linear equation? Simultaneous linear equation, you will see that we are going to use the variable as an independent variable, right? And where do we use it here? To calculate the cost, determining break even point in profit loss or running any business, or modeling speed and distance here. Then common applications, you will see finding the cost or price of the item, comparing services plans and engineering field, economics, logistics. So there are a lot of applications of these kind of equations. So how do we solve it, right? So which kind of equations we will be taking in simultaneous equation. Then later on we will see how do we solve algebraically, graphically, and we are going to take the exam based questions also here. Now these are your exam based questions, so we'll consider that. Now, if I take linear equation with one variable, you see here the variable is x and the highest power here it is 1. So we call it as a linear equation with one variable. Now, if I simplify this, I'm going to get here 4x is equals to 24, x is going to be equals to 6. So we are getting this a specific value which is going to satisfy this equation. If I substitute back here x as 6, then 6 minus 2 is 4, 4 times 4 is 16. So this is called unique solution. Now here if you will see unique solution, because there is only one variable, we can put it on the number line, the solution, where which value, which place is going to represent this value here. I can take it here. This is x is equals to 6, which is representing here the value. But in higher classes, you don't learn linear equation in one variable. You learn linear equation in two variables. So here, if I take linear equation, now still I'm talking about only one equation, linear equation with two variables. That means you are going to relate two of the variables. That means it is you are going to consider the plane. Your graph is going to be the Cartesian plane. There will be x-axis, there will be y-axis, because we are having here two variables, right? So one is going to be independent variable, another is going to be dependent variable. Sometimes you use this in function also. I can write down here a function of fx which is representing some function machine, right? So linear equation with two variable. Now how do we get it here? Whenever you are having linear equation in two variable, you get, there are two ways you can get it here. And which kind of graph do you get it here? It is linear equation in two variable. You will always get the graph as a straight line, right? It is always straight line. So what are the two forms whenever you are talking about the linear equation with two variables here? The first one, you know that it is going to be here the gradient intercept form. Whenever you are learning about the linear equation, the first form is y equals to mx plus c here, which is known as here. So first form, when you take the linear equation, this is called here gradient intercept form, right? Here intercept form of a straight line, because linear equation will always give you the graph as a straight line. So y is equals to mx plus c. Here x is nothing but here independent variable, and y value is called here dependent on x, right? So this is independent variable, this is called here dependent variable, dependent variable. And what is the m here? M, if you take it, that's called gradient. Here M is known as gradient. Gradient you have already learned, it is y2 minus y1 by x2 minus x1. That means this is called change in y by change in x, right? Or which you can take it here, rise over run. Now, how do we take it here? If I'm taking one of the examples, so here, and this is the gradient that we'll see one example, and C is always your y-intercept. You have seen this in the coordinate geometry also. But we are talking about the linear equation, so this you should know. This is called gradient form in the linear equation also. Other than that, you will see the standard form of a straight line, which is a linear equation. Straight line means it's always a linear equation. So here, if I see, this is also, you have to remember, this is called gradient form, gradient intercept form. What is the standard form? Here you will see always ax plus by plus c, which is 0, where a, b, c are integers and x and y are the variables, right? Now, let me take one example here where you will form the linear equation here, right? So here, if I'm taking this one straight line. Now this is straight line. Now how are you going to get the straight line equation here? What is the gradient? So this is nothing but straight line. Straight line means you are going to get here y is equals to mx plus c, because your simultaneous equation is going to be integrated with function or coordinate geometry sometime. So let us take it here. So here y is equals to mx plus c. So find here, if the question says, the first question is find the gradient of the line, right? Gradient of this line, straight line. Now, if you see the straight line, I have said rise over run. Now here, from this point to this point, if you see from here, if I'm coming down, this means this is going to be rise. Or from this point, I have to take this and I have to take then left turn to get to reach to the other point B. So if I take this point as A, this point as B, now to reach rise over run here, so I can here count. If you see this, this is the rise. So gradient change in y by change in x. So you can take any 2 points. You can take y2 minus y1 by x2 minus x1 also. I'm first telling you in terms of rise over run. So how much rise you have taken? 1, 2, 3, 4, 5, 6, 7 units up. And whenever it's going up, it is always positive. If anything is going down, it will be negative. Similarly, on the horizontal side, right side is always positive, left side is always negative. Now, after reaching here, to reach to B, I have to go 2 units left. Now, left means it will be minus 2. So what is your gradient here? Minus 7 by 2 using rise over run. If you want to use y2 minus y1 by x2 minus x1, this is your x1 y1. If I take it, this you take it as x2 y2. Then you can take here minus 5 minus 2 by 1, and then minus of minus 1, which is nothing but minus 7 by 2. So any method you can find out. Sometime if the coordinates are not given, you can find out any 2 points coordinate and you can get it. So what is going to be M? You got it. Now where this line is cutting here, y axis, that's called y-intercept, right, which is going to be your c value. So if I need the exact value, so y is mx plus c, what you can do here, because this is exactly in the middle, you can take 1.5 also here directly. You can see here it is 1.5, or you can substitute one of the coordinates to get the value of c. So if I'm substituting first m value minus 7 by 2x plus c, and if I take it here 1 and minus 5 as the coordinate a, substitute here, it is minus 5 minus 7 by 2 times 1 plus c. To get the value of c, minus 5 plus here 3.5, which is nothing but minus 1.5. You can see here also, when you see the graph, y-intercept is looking at minus 1.5 or minus 3 by 2. So what can I write down? What is the equation of the line here? Y is minus 7 by 2x minus 3 by 2. Why am I writing here minus 3 by 2? Because the first gradient is written in the fractional form. So the y-intercept also should be written in the fractional form. Now this is called here gradient form in a linear equation. This is called gradient form, right? Gradient intercept form of the linear equation. This is gradient there is a gradient, there is a y-intercept, that's why we call it as gradient intercept form. Now, if I need to find out here standard form, because when you are solving the equations, linear equation, you must know the standard. We are going to use here standard form. So what I can do here, 2 is the common. I can write down 2y as minus 7x minus 3, and you know that ax plus by plus c, which is equals to 0, is the standard form. So I can bring everything to the left hand side. It will become 7x plus 2y plus 3, which is equals to 0. This is the standard form of a linear equation. Now, how many solutions do you get it here? How do you get? Because first thing is getting the equation, identifying whether it's a linear equation or not. After that, how do you solve it? So here, solving linear equations. See, till now I have not taken simultaneous equation, right? So solving linear equation, when you solve here linear equation, you get one unique solution, right? Here there was one unique solution because there was one variable. Now here, if you will see, my number of equation is here 1, which is, so I am having here y, you can write on anything, gradient intercept form. If I write on, it is minus 7x minus 3 by 2. Right now here, how many solutions do you get it? Because this is one equation with two variable, there will be infinite solutions. How do you get here infinite solution? Because one equation, I can take any, x is the independent variable, I can take any value of x, I'll get one specific value of y, right? So first, if I substitute x as 0, it will, y will be minus 3 by 2. If I take y as 0, then if I take here y, this one will become 0, then it will be minus 3 by 7. Right? If I substitute x as 1, minus 7 minus 3, which is minus 10 by 2, which will be minus 5. So these are called ordered pair, so which is going to represent a point. So what is going to be the first coordinate? 0 comma minus 3 by 2, here minus 3 by 7 comma 0, then here 1 minus 5. So in this way, if you take it, you can substitute their infinite values. If I put here 2, then 7 2s are 14, it will be minus 17 by 2. If I substitute here 3, then it is going to be minus 12 and so on. You can put here negative and positive, any kind of value. So that's why whenever you have one linear equation with two variables, you get infinite solution. So here if I see a straight line, because the straight line can be extended infinitely, and every point on this line, there are infinite point on this line, every point is going to be represented by one ordered pair, which is the x and y coordinate, is going to satisfy this equation. That is why when we are having one linear equation, we always have infinite solution. There's no unique solution. Now after this, when you talk about system of linear equation, or if I take here simultaneous linear equation. Now here, if we talk about the simultaneous linear equation, that means there are going to be two equations. So if I'm having here y is equals to m1x plus here c1, and then y is equals to m2x plus c2. If these are the two equation, now if you will see here, the highest power is 1. So this is called, because you are taking two equations together, that's why we call it as simultaneous linear equation. Now what could be the possible solution here? So what is the system of equation? If two or more equations with the same unknown, solving a system of equation means finding the value for each unknown. Unknown means it's going to be variable that satisfy every equation in the system. That means if I'm getting a solution x comma y, it will be an ordered pair. If I'm getting a solution, it should satisfy my first equation as well as second equation. Now, what could be the possible solutions here? There is going to be only the 3 to 4 different criteria here. The first one, whenever you get a unique solution, so this is your case 1, I get a unique solution. Whenever unique solution means it is going to be one by intersecting at a point, right? So it is going to be here because these are the straight line graphs. So you will call it as intersecting lines because each of the equation is going to give you here one straight line. So wherever these, if I write on here, this is equation 1, this is equation 2, wherever they intersect these two lines, that point of intersection is called, it's a unique solution, which is x comma y, written as a ordered way. So at this point, if I take this point as p, point p falls in both the straight line, that is why it is going to satisfy both the equation, right? So but in every case we don't get intersecting line. We will get intersecting line whenever they will tell you to solve the algebraic equation algebraically or graphically. Then what could be the second case in coordinate geometry? You have learned here the second case here can be here parallel line, right? So parallel lines, if I take line 2 and line 1, if they are parallel lines, then you will never get a solution because here they are not going to intersect at any of the place. So the graph is going to be here two straight line, here line 1, line 2, they are not meeting at any point. But here you must remember, here we always take the gradients are equal. If the lines are parallel, m1 is equals to m2, or we can call it here gradients are equal. This you have learned in coordinate geometry as well. Gradients are equal. So what could be the third case you are getting here? So now case 3, there is again going to be a unique, see first case intersecting line, but you know that all the perpendicular lines are intersecting lines at 90 degrees. So perpendicular lines also will have a unique solution, and here unique solution, and their point of intersection is going to be their unique solution, which is going to satisfy both the equations. So here also they are intersecting, but they are intersecting at 90 degree. Now you are not going to do the construction here, right? So how are we going to decide whether they are perpendicular line or intersecting line here? So if this is line 1, this is line 2. Here you should know their gradients are negative reciprocal to each other. Or I can write on m1 is minus 1 by m2, or m2 is minus 1 by m1. This also you have learned in coordinate geometry as the rule. So the product of both the gradients is always 1. So you can see that in case 1 and case 3, you are going to get the unique solution because it has to intersect to get the unique solution. Now there is one more case here, one more case that you see in very rare places, which is called, because the lines can be, these are the different types of lines: intersecting line, perpendicular line, parallel line, or if you know that there can be coincident lines also. That means the lines which are falling on each other here. Two lines, if I take it here on top of each other, then they are called it as here first equation. This is line 2, right? Any line 1, line 2 here. Coincident line also, there will be infinite solution. Now infinite solutions means we can't find out by solving it. Infinite solution also, when you are writing, that means you can't write on any unique solution. You can't write on one answer. But in this case also, you will have here the gradients are going to be equal and their intercepts are also equal. That means they are going to fall on each other. Generally, you don't see this part in much places, correct? So how do we solve now algebraically? So we will see how do we solve simultaneous equations algebraically, then graphically also. So here, take it here, solving simultaneous linear equations algebraically, linear equations, right? So because why am I writing every time linear equation? Because you can have simultaneous non-linear equation also. So algebraically and graphically, I'll take it both together, okay? algebraically using two methods here. First one, you will take it as substitution method, and the second one you will take it as elimination method. These are the two methods where you don't use graph to solve it. So this is called elimination method, right? So algebraically here when we are solving, and here graphically, that means by seeing the graph wherever they intersect also, you know that you need to solve it, because when you solve you will understand whether it's a intersecting at a point, then there will be a unique solution. So let us take one example. Now here one question is given, it's written here, use the method of substitution to solve the system of equation, means simultaneous equation. There are two equations, then check the solution. So we are going to take here algebraically and graphically both, right? So how do we, because when they say substitution method means it is going to be solved algebraically, and we will cross verify that how, what is the solution when we are solving it graphically. Right, so here let us take the first equation here, 7x plus 2y is equals to 90, and x minus 4 is equals to x minus y is equals to 4. So see, wherever you see the coefficient as 1 here, right, here x coefficient is 1. So from this equation you are going to substitute on the other equation. So this is my first equation. If I rearrange this, I can write down this as y plus 4. This is my second equation after rearranging x minus y is equals to 4 in this form. Now you can see that you are having the value of x. So what I'll do here, substitute here, because you need to take the value of the variable from one equation and substitute in the other equation. So substitute x in equation 1. Now equation 1, wherever you see x, so it is 7 times x, so it will become 7 times y plus 4 plus 2y is equals to 19. Now you can see that your two variable equation you have converted into one variable, which is y, and from here you can get the value of y. Right, so simplify this, you will get 9y is going to be 19 minus 28. So this is going to be here, 9y will be minus 9, y will be minus 1. So I'm getting a unique value of y, which is minus 1. And now from equation 2, if I substitute here in equation 2, which is x is y plus 4, then I can get the value of x also. You can substitute in any of the equation, 1 or 2, to get the value of the other variable. So x is 3. Now here if you write down in the ordered pair form here, what is going to be your ordered pair? Which is going to be 3 comma minus 1. That means this point is going to be point of intersection, because whenever you are getting one ordered pair, the lines are definitely going to intersect. It can be intersecting or perpendicular lines, that we don't need to check, but whenever you get a unique solution, it is always intersecting line. How can we verify? If I substitute 3 comma minus 1 in both the equation, it should satisfy the equation. So it is 3 comma minus 1. You can always cross check your answer. 7 threes are 21 minus 2, it is 19. We are reaching to the right hand side, and left hand side you substitute x and y. 3 minus of minus 1 will be 4, and right hand side is 4. That means my answer is right. So this is the way algebraically, this is using substitution method, you got the solution. Now the same thing, how are you going to solve it graphically? The same question, because you know that each equation is a linear equation, so you will get a straight line for each equation. If you want to solve it, you will always get x and y intercept. So here, what is my first equation? 7x plus 2y is equals to 9. And second equation is x minus y is equals to 4, right? Here it is 19. So what can I get it here? How do we get the solution here? I can do this here. I can take x value. If I substitute and y value, if I substitute x as 0, you get 2y is equals to 19. So y is going to be equals to 9.5. If I put y as 0, then you are getting here 19 by 7. So because 19 by 7, it is not a value which we can use technology to put it here, but I can take any other value also so that you will be able to get the feasible answer. If I substitute x as 1, now 7 ones are 7, then 19 minus 7, it is going to be 12. So y value will be 6, right? So these values, these three values, you can put it on your graph to get a straight line. Similarly, for the second equation, I can get ordered pair and minimum 3 solution or x and y intercept. So if x is 0, y is minus 4. If y is 0, x is 4. So these are the two solutions. If I'm going to draw the graph for this, graph is like this, right? They have written the gradient form and they have solved it. If you will see, you can see the point of intersection is written as 3 comma minus 1, right? So here it is, if I extend this also, it is y intercept is going to be minus 4. You can see that. This is the equation. Red color line is the equation of second line here, second equation, and the first one, this is the first one. Now point of intersection is coming as 3 comma minus 1. So these are the intersection line. So here also when you are solving algebraically, you are getting 3 comma minus 1. So graphically and algebraically, both are the same thing. Now let us go for the second method, which is elimination method. Now this is the another example which we will solve using elimination method. Now if I'm talking about elimination method means while we have to add or subtract the equation such that one of the variables should be eliminated. Now here if it is given in this form, first you will rearrange it as 3x minus y. So your variables are to one of the side, left hand side, and the constant is to the other side. X by 5 plus y by 2 is equals to 0. The LCM is here 10, so you can get it here 2x plus 5y by 10 is equals to 0. Now right hand side is 0, I can take 10 times 0 is going to be here 0. So 2x plus 5y is equals to 0 is your another equation. So here I can write down 2x plus 5y is equals to 0. Now if you observe this, these are my two equations. So what do we do here? We make one of the coefficient, one of the variable coefficient same so that while adding or subtracting, I can remove that variable term. Now here if you see the coefficient is 3, here the coefficient of x is 2. Now they are not same. To take the LCM of their coefficients. So 3 and 2 LCM it is 6. So I can multiply here 2, I can multiply here 3. So I'll get it here 6x, here also I'll get 6x. And because 6x and 6x, x will be eliminated if I subtract. But you can eliminate here y also. Now here look at here, there's no coefficient in y, so that means it's 1. Here coefficient of y is 5. So either you can multiply something in both the equation or any one. Here if I take try to make the same coefficient of y, I know this is easier because I need to multiply the whole first equation with 5. So first do that here, it will become 15x because 5 will get multiplied with each term both the side of the equation. Minus 5y is equals to here 85. Right, 17 fives also you will do it. Don't forget to multiply to the right hand side as well. Now after this, the second equation you will write on as it is. Now if you will see, the coefficients are same with the opposite sign. If they are with already with opposite sign, you are going to add the equations. The equation, what do we get it here? You will just add or subtract vertically here. You know that this will get cancelled. Negative 5y positive 5y will become 0 and 15x plus 2x will become 17x and 85 plus 0 will become here 85. Correct? So x is going to be equals to 85 by 17, which is 5. So we are already getting x value, which is 5, and using first or second equation I can get the value of x y as well. Now this is looking easier because it is just 5y will be equals to minus 2x. So substitute here in the equation 2x as 5 2s are 10, so 5y will be equals to minus 10. Y will be equals to here, if I take here y, that will be equals to minus 2. So what is your solution here? Unique solution here, which is in the form of ordered pair 5 comma minus 2. That means both the lines, because it is going to be the graph will be straight line, are going to intersect at 5 comma minus 2. Now this is one of the thing where you are eliminating the variable y. What happens if I want to eliminate variable x? Now if I want to eliminate here variable x, if I take, because you should know both the ways, right? So simplification of equation is going to be same. After that, 3x minus y is 17. This is or, right? Any one you have to do it. Now here plus 5y is 0. Now if I see the coefficient of x, here it is 3, here it is 2. To make it same, I'll multiply the first equation with 2 and second equation with 3, because here 3 2s are 6, then only you will get the 3 and 2 LCM is 6, so that's why I have to multiply this. Now multiply 6x minus 2y is 34. Here 6x plus 15y is equals to 0. Now here if you will see, your coefficients are same sign, plus 6 and plus 6. If you add, you won't be able to eliminate x. So you do subtraction. I'll just, whenever there is subtraction sign, positive into negative is negative, positive into negative will become negative. Here also positive or negative of 0 does not matter. So you are not writing any sign or you are writing sign, it's not going to impact the value. Now you can see here, you will take the new sign which is negative, this gets cancelled. Minus 2 minus 15 now, because now the 15 positive to negative, because whenever you subtract, sign of each term will change. So it is minus 17y, which is 34. 34 minus 0 is 34. Y will be equals to minus 2. You can see you are reaching to the same answer. Now substitute in any one equation here 2. So if I put it in the first equation, so y is minus 2, negative of negative 2 will be positive 2, 15, 17 minus 2 is 15. So 3x is 15, x is 5. You can see here the equation, the ordered pair is coming here the same 5 comma minus 2. So any method you do it, you eliminate any of the variable, your answer is going to be always same. Now how the graph will look here, the same thing, you will take it here, x and y intercept, and they both the lines are going to intersect. See, this is already graph is there, you can see this point of intersection. If I take it, if I increase little bit size here, you'll be able to see here point of intersection, it is 5 and minus 2, that you have already got it in the, when you have solved it algebraically, right? So here this is the way you solve. So again you are getting intersecting line, only any kind of intersecting or perpendicular line will give you the unique solution. Now sometime you get here, you need to find out, because x is equals to a and y is equals to b, how are you going to get the graph of these kind of equation? Now you need to remember, because there is here no y coordinate, no y in first equation, and here there's no x value in the second one, y is equals to b. Whenever we have x is equals to a, it is always parallel to y axis, that you have to remember, right? So x is equals to minus a. So here what is fixed? X is fixed here, and x is fixed, that means the gradient is going to be not defined, right? Because here you know that the gradient is y2 minus y1 by x2 minus x1. Now x1 and x2 is fixed, representing the same value. That means for any y value the denominator is 0. That means whenever there is a vertical line, gradient is not defined, right? We will never get any gradient if it is parallel to y-axis. Similarly, if I'm having y is equals to b, I can take it here. It is going to be, you can remember as here parallel to y-axis, right? Similarly, y equals to b will be parallel to x-axis, parallel to x-axis. right? So here if this is x coordinate, this is y coordinate, this is the origin. Whenever we are drawing y is equals to b, it is because this is going to be y is equals to 0. Positive value will go above, this can be y equals to b. So you can see that here y is fixed, which is b. Here also if I take it as y is equals to minus b. Similarly, y-axis means x is equals to 0. Whenever we have this, this is parallel to x-axis, your gradient y2 minus y1, because these two are the same value by x2 minus x1. You know that for everything y is same, right? That means this one will become 0 by for any x value. You will get 0 divided by anything 0. So whenever the line is parallel to x-axis, you always get gradient as 0. And here gradient is not defined if it is parallel to y-axis. Now, if I need to show this in one graph, if I say here, example, what will be the solution of x is equals to 4 and y is equals to minus 5. You can see that if I try to draw the graph on the same plane, this is x, this is y. Now, where will be x is equals to 4 to the positive direction of x? So, I can draw a straight line which is representing x is equals to 4. Now y is equals to 5 if I take it here 1, 2, 3, 4, 5, right? 5, you know that if I extend this, this is going to be somewhere minus 5. You can see that this is your y is equals to 5. Wherever they both intersect, because they both are going to intersect at one place here, which is if this is x is equals to 4, this is 5, you know that this is your 4. 1, 2, 3, 4. Right? This is 5. So intersection will be the coordinates. So what is going to be the solution in this case? It will be 4 comma minus 5. Now here, if I take, there is another type of simultaneous equation which we call it as non-linear simultaneous equation. This means one of the equation you get it as here linear equation and another one you get it as a quadratic equation. If I'm writing here y is equals to x square plus bx plus c, right here. So this is your quadratic equation. Whenever we have this, we will not have elimination method. We'll have only substitution method. Now in substitution method, you are going to substitute the value always from the linear equation to quadratic equation. So here from linear equation to quadratic equation, you substitute the x or y variable value. Now what is going to be the graph? If you will see here, graph is going to be the intersection of parabola, because the graph here, it is going to be parabola. Whenever we are having here a quadratic equation, we always get parabola. Here we get straight line. So whenever you are having this case, means intersection of parabola and straight line, then what do we take here? Respective x coordinate of that intersection point. Respective x coordinates are going to be the solution. Coordinates are the solution. So how do we take it here? Let us see one example and then you will understand. Mostly this kind of question you get it in exam. So first we are going to follow substitution method. This is nothing but algebraic method, right? So this is algebraically we are solving using substitution method. Graphically means we are going to intersection of both the graphs. So this is here now solve the simultaneous equation. So here first you need to identify whether it's a linear simultaneous equation or non-linear simultaneous equation. So y is equals to x minus 4, it is a linear equation. Linear function also you can say, because it's equating this, and here if you will see, this is a quadratic equation or quadratic function, right? So what do we do here? I am already having y value in my first equation. So, and what is the second one here? Second equation, x square minus 4x plus 2. This is the second equation. Now, what do you do here? Substitute y here, substitute y from first equation to second equation. equation. Now, if I do that, x square minus 4x plus 2, which will be equals to x minus 4. The moment, and now here the highest power is 2, means this is nothing but a quadratic equation. And whenever I solve the quadratic equation, I always get the standard form by taking everything to one of the side of the equation. So x square minus 5x plus 6 is equals to 0. Now this is nothing but in the form of ax square plus bx plus c, which is equals to 0. So you can get roots or zeros of solution of x. How do we do it here? You can follow here splitting the middle term method. So this is 6. 6 means 1 times 6, you can take it here. 6, it is positive 6, so you can take 1 times 6, you can take 2 times 3 also, because here, but I need here the product should be positive, so they both should be 1. See, I can get here also minus 5, but the product will become negative 6, so I have to take minus 2 minus 3, x square as it is minus 2x minus 3x plus 6. So you have to always see the sign of the product and the middle term both. So after that you do the grouping. You can take here x is common, x minus 2 minus 3 is common, x minus 2, which is 0, and they get the factorized form x minus 2 times x minus 3, which is going to be equals to 0. Now after this, if I take x minus 2 is equals to 0 or x minus 3, which is going to be equals to 0. So what are your two solutions, 2 or 3? These are the two possible solution, where that means the wherever the parabola and the straight line curves, the respective x coordinate is going to be 2, 3. Now here you need to get the y coordinate also, because you will substitute in first equation y is equals to x minus 4, so that will be easy, because y is x minus 4, so I can take it here. If x is 2, y will become here minus 2. So if x is 3, y will become, you substitute in this equation 3, 3 minus 4 is going to be minus 1. So therefore, what are going to be the solution here? If I'm taking the solution, means intersection of both the graph 2 comma minus 2 and here 3 comma minus 1. Now if you use the graph, which is parabola is representing the first equation and y equals to x minus 4 is representing the straight line. Now these graphs are parabola and straight line is cutting at 2 points. If I take point A and B, you can see that the coordinates of A is 2 comma minus 2, which is 2 comma minus 2, and B is 3 comma 1, because here if you'll see it is 3 comma minus 1. So these are the two solutions. So whenever you have a parabola, and this is called a linear equation, we call it as non-linear simultaneous equation. Now let us see here exam based questions. Now in exam, this topic where you learn simultaneous linear equation or simultaneous non-linear equation, you will see the weightage will be 7 to 8 marks out of 100, right? This is going to be 7 to 8 marks. So let us see what is the, it's given here 7-mark question. What is written? Label the graph by dragging the matching equation to the correct place. So here already the graph is given, right? Now here you know that anything which is parallel to x-axis will be in the form of y is equals to b. Anything which is parallel to y-axis will be in the form of x is something, right? Now because it is in the positive direction, it cannot be minus 3. So this has to be positive 3. So what is going to be this vertical line? X is equals to 3. Similarly here, if I'm going to the negative direction, this has to be negative. So we cannot have y is equals to 3. This is going to be minus 3. This part is minus 3. So this will be y is equals to minus 3. Because whenever there is a vertical or horizontal line, vertical line will be in the x is equals to any constant form, and horizontal line will be y equals to b form. So your correct answer is these two. You are going to take it here. Remember, vertical line is not y is equals to minus 3. It is in the form of x is equals to a. Similarly, next one here, if you see, these are the two intersecting lines. Now, two intersecting lines, they are intersecting at the same y-intercept, if you will see. Now, same y-intercept means it can be this or minus 3 and minus 3, because they both are given in the gradient form, right? So, here the gradient y-intercept is same. So, what? If I take it here, it is not, because there is no other coordinates given. So you need to read the equation carefully because it is intersecting at the negative side. So you know that y-intercept cannot be positive. So you have rejected the first and third answer. Now both you look at here, whenever my line goes to left to right, there will be positive gradient, and if it is coming left to right, it is going to be negative gradient. So apply that rule. Now here in the first one here, if you will see the negative gradient, it will be y is minus 2x minus 3 because your y-intercept will be minus 3 here, right? And similarly here it is going to be positive gradient, which is 2 y is equals to 2x minus 3. You can see that they both are cutting at y-intercept, which is minus 3, and one is having positive gradient, another one is having negative gradient. Right? So always whenever it's going like this, positive correlation or positive gradient. If it's coming like this is going to be always having negative gradient. This is negative m, this is always going to be a positive m. Steeper the gradient, it is going to be bigger the value. Other than this, you can see that these are the parallel lines, right? And parallel lines, you have to remember the gradients are equal, right? Now here, look at here, the gradients are equal. First, you need to get it in the gradient form here. So each one here, the y-intercept is negative. For blue color line, y-intercept is positive. So first get it into the gradient form because there's no other coordinates, no other values are given. So you should know how to read the equation. So this one will become y will be equals to, if I make y as a subject, it will become y is equals to minus x plus 3 by 2, here also by 2. So here the gradient is negative. But here you see both lines are going in the right side direction. So in both the cases here, the positive gradient will be there. Right? It can't be negative because parallel line gradients are going to be equal, but it's going to be positive. Again, and here we are having negative gradient minus 1 by 2. So the first is not possible. Here y is equals to minus x plus 3, here also by 2 by 2. Again you are getting negative. Y is equals to x minus 3 here, then by 2, this is also by 2, and this one will be x plus 3 and y is equals to by 2 and by 2. Now here they both are the parallel line. One is cutting in the negative. So this is going to be y-intercept is minus 3 by 2. This is plus 3 by 2. And both side gradient is going to be 1 by 2. So you will take here the blue color line. What are you going to drag here? This is going to be this one, right? So please, because you need to drag the same, the given equation form, it is positive gradient, positive y-intercept. Here, the positive same gradient, which is half, and negative y-intercept. So this is the way you will find out. Now the next figure, if you will see, there are two parabolas. Drag the correct one. Now first thing, if you have to observe, this is cutting at a negative side, this is cutting at positive side. So one of the zeros is common because here you can see they are cutting at the same point and their y-intercept is also same, which is positive. This also they are intersecting at this. Now it's already given in the factorized form. So get the zeros first. Here, write the solution. So here the solution or zeros, and you get here y-intercept to understand this. Now the first one, the zeros are going to be minus 1, minus 3 because you will equate each one with 0. And your y-intercept is going to be 1 times 3 because whenever I am having ax square plus bx plus c, y-intercept is always c. So it is going to be positive 3. Right? Similarly here, your solutions are 1 comma 3 and y-intercept is positive 3. And here if I take the solutions are here 1 and minus 3. Here also it is plus 3 because you are going to multiply this. Now one more thing here you need to remember, whenever it is downward parabola, it is A is negative, upward parabola A is positive. And you can see that here this is cutting at 3, right? And here it is, if you simplify this, it is minus x square, then minus here minus 3x plus x will be minus 2x is going to be upward parabola. Another one is going to be downward parabola. Now here, which solution is going to have here? Now this one, if you will see, the y-intercept is positive 3 and it is downward parabola. One of the value is here minus positive root. This is negative root. So this is going to be the green color parabola, downward parabola solution. Y is equals to here 1 minus x, x plus 3. So you can get the zeros. You can get here the y-intercept is positive 3. It is downward parabola because x square coefficient is here negative and minus 3. One of the root is negative, another one root is positive. Now what is going to be, because we already got one of the root here which is going to be 1. Right now here this is upward parabola, means x square should be positive, so it can't be third one. We have it can't be third one because third one is having x square coefficient negative, and fourth we have already taken for this. So among these two, if you see, both the solutions are positive. Now here if you'll see, both the roots are negative, so this is going to be your second quadratic equation. It is going to be the solution of this. So you need to read the roots, solutions, y-intercept, upward, downward parabola to identify which equation is going to represent the given parabola. Let us go for the next question. Now this is your next question here. If you will see, it's given in the function form. Total here the weightage is 6 marks, right? What is given here? F of x is 1 minus 3x. This one we can write on y is equals to 1 minus 3x also, because function can be written as f of x or y equals to 1 minus 3x. Here again gx is going to be equals to, this is another one, x square plus x minus 4. Now, one of your function is given as here in this question, f of x, it's given in the function form. It is 1 minus 3x, and another function is x square plus x minus 4. You can see that this is a straight line, this is a parabola. Now, it's given fx is equals to gx. So here again, simultaneous equation it's given. This is why, this is also why you can equate, because they have given they are equal. So what are you going to take it here? X square plus x minus 4. This is your 4a part is equals to, here if I take it, 1 minus 3x, because they both are equal. Now you know that this is a quadratic equation. Get the simplest form here. Minus 1 plus 3x is equals to 0. So x square plus 4x minus 5 is equals to 0. You can see that here the product is minus 5. So you can take only 1 into 5. This bigger number has to be positive, smaller number has to be negative, because the middle term it is plus 4x. So how are you going to do the splitting the middle term, and product of these two numbers, you can see it's minus 5. So x square, then here I can write on minus x plus 5x minus 5, because here sum and product both signs should match. Then here if I do the grouping part, x is common, x minus 1 plus 5, here x minus 1 is 0. Then we get it here, x minus 1 times x plus 5, which is going to be 0. So the solution is going to be 1 or minus 5. So you are getting here two x coordinates. Now if you observe this here, one of the coordinate you can see here, x is negative side, another one it is to the positive side. Then how do you get the y value? You can substitute in 1 minus 3x. So if I take y as 1 minus 3x, what is going to be, if x is 1, y will become here, substitute 1, it will become 1 minus 3, which is minus 2. If x is minus 5, y will become here minus, negative of negative will be positive, 1 plus 15 is going to be 16. So what are going to be the intersection coordinates? Because a is to the negative side, this will be minus 5, 16. Here somewhere it will be here, the y it will be 16, and b's coordinate, because it is to the positive side, it will be 1 comma minus 2. You can see that here the y coordinate is to the negative side. Right, so we got here first fx solve means you are getting x value, right? And here the y value also you can get it. Now what is written in B part? The solution of fx and gx are the x coordinate of the point AB shown in the following graph. That using A find the values of y coordinates. So this part will go in 4B that I have solved. X coordinates you will get it in part A, and when you substitute x and y you will get coordinates in y, the another one. So what are your solution? You can write on here solution. So A's coordinate is minus 5 comma 16 and B's coordinate is 1 comma minus 2. So these are the two solutions. Thank you for watching this video. Please like, share and subscribe. Also keep practicing.